Hi everyone, welcome to the very last video of Unit 2. And this video is where we're actually going to learn about the second thing mentioned here, which is if statements. So what is this all about? There's a couple names for this concept. One is branching. And another name for this idea is conditionals, or conditional execution. And what this is all about, if you will indulge me for an illustration for a second, is that we have like a river. This is our program flowing downhill. And so far, this is how our program looks. It's just like one stream of water. You have each statement along the way here. They all get executed one at a time. So when I run your program as it is now, I know exactly which statements are going to get executed ahead of time because they're just the statements in your program, the first one, then the second one, then the third one, and then that's done. So this actually has a name. This type of thing is called a straight line program. And you can kind of see why it's called a straight line program, because there's just a straight line from the top to the bottom of your code in terms of what gets executed. But there's actually, it's kind of a restrictive model of execution. People study straight line programs a lot in terms of theoretically, like how much can you do when you just have one stream of statements and you never diverge from that. But as you've probably guessed, branching is going to be about our stream flowing, and then forking off. So you can either go over here or you can either go over here. And typically the way that branching is going to work for us is that they'll also come back together at the end. So we'll have, imagine there's kind of like a bend in the middle of the river, and it can go on one side or the other. If you're floating down on a raft, then you'll come back together like that. And so this part here, this is what's called a branch or conditional execution, and that's because you could either, when you're running the program, so think of a run of the program as like you're sitting on the tube as you go floating down, you could either go down this way, down that side, or you could go down this way, down that side. And the key is that we don't know ahead of time which branch, which way it's going to happen. So this is a branching program. So we'll see in a second what this looks like in C and how we actually program this up. And if you've done pretty much any programming in any programming language before, you'll know what this is about an if, but you might not have thought about it exactly this way before. And so this spot right here, where we decide kind of which side we're going to go on, this is the decision point. And usually there's a condition involved here. So depending on the outcome of this condition will determine which side which side of the river, as it were, you might go down. So what we're going to see is a new kind of construction in C that's called an if statement that allows us to decide whether the program should do one thing or the other. And of course, once we have this basic idea, one of the really cool things, and what we're going to see in this section, is that then we can extend that again and again and again. We can get more branches and branches in branches and branches after branches. And so just with this little idea of like, oh, you can go one of two different ways, it adds essentially an exponential. And I know people use the word exponential kind of loosely these days to mean a lot. But here I actually mean it literally. It's an exponential increase in the number of paths that your program can possibly take, and therefore in the potential complexity and interesting problems that you can solve with your programs. Okay, so let's get out of this illustrative conceptual world and get down to business of what are we actually talking about. The way it works is that you just use the word if. So if is a special keyword in C. IF. And then we have parentheses, and what goes inside parentheses is the condition that's going to determine which side of the branch we take. And then typically we'll use like this. Okay, so what I'm drawing here, these are curly braces. The things that actually are the beginning and end of main. So then what are the different pieces here? So inside the parentheses here, this is going to be a condition that's evaluated as a bool. Condition, which is going to be some expression that is evaluated as a bool, meaning it's going to either evaluate to true or to false. So we could put literally like true in here or false, but usually that wouldn't be very useful. A lot of times this will be based on a variable or something, or some kind of test or a comparison between two numbers, that kind of thing. And then here we have any amount of statements that will be executed if the condition is true. If the condition was true, because remember, we're evaluating this condition as a bool, so it'll either be true or false. And then down here we have any amount of statements that'll get executed if the condition is false. If condition was false. So that's the basic structure. So what's going to go in here is an expression, and what's going to go into these second two red boxes are statements. And remember from the last section, we talked about what the difference between that is. An expression is something that has a value, so it could be a variable, it could be like an arithmetic expression or something, but it'll evaluate to a value, and that value will essentially be cast to a bool if it's not a bool already, because it needs to be determined, is it true or false. And then here will be statements, by which we mean like semicolon statements, assignments, or prints, or things like that. And same with what goes in statements down here. Enough hypothetical talk. Let's look at an example. So here we have, I'm going to make a small program called temps.c. And I've already started it, but what this is going to do is just ask, what is the temperature? And then based on the temperature, it's going to give us one of a couple of messages. Okay, so I'm going to read in the temperature as a double. If you think about it, double makes sense for the temperature because it can be kind of continuously variable. It doesn't have to be an integer value. We'll assume Fahrenheit because we're in the US. And now let's make my if statement. And let's say right now we're trying to decide if it's too hot to go outside. So if the temp is greater than or equal to 90, then we will print a message like, it's too dang hot outside. And that'll be it. And otherwise, we'll print a message that says, it's nice outside. Okay, so here's our whole program. And this right here, this if-else thing, this is our conditional execution part of it. So we have the condition is right here. It's comparing the temperature value to 90. And then here's the kind of if block. What happens if that's true, if temperature is indeed greater than or equal to 90? And here's what happens if it's false, if the temperature is less than 90. Notice that we can't actually use the like greater than mathematical symbol in code. Of course, there's no good way to type that. So this is how you write greater than or equal to in C. It's just a greater sign and then an equal sign. Okay, let's give this a shot. So we will say gcc temps.c, compile, that's good. What is the temperature? Right now it's actually kind of nice, maybe 82. So yes, it's nice outside. One thing that you'll notice right away with when you're writing programs with if statements is we have to do more testing, right? So if I just stopped it there, just stopped it with trying in 82, I have no confidence that my program works correctly because maybe it always says it's nice outside. It's, when you're doing something like a binary numbers or a conversion, if you try one example, you shouldn't feel that good, but you might feel some confidence. Like if I can convert one number from inches to centimeters, then probably I have the formula right, at least. Maybe there's some details that I need to do some more testing on, but mostly like, hey, I feel pretty good. When you have if statements, you have to definitely make sure that you at least get to both parts of the condition of the if statement, or else your testing is useless. So I definitely need to test some high temperature. And that worked. It's usually a good idea to test something right on the borderline, so 90 exactly. Let's think about what our program should do. Well, here we had the condition if it's greater than or equal to 90. So if it's equal to 90, that means that it is too dang hot outside. But if it were like 89.9 degrees, then we would call that nice, according to this program. Now, let's think a little bit more about what we can do with this and what this means. First thing to emphasize is that we can really put any statement inside here. So we could have another whole program. We could have another print statement here, like you should go enjoy it. This has nothing to do with my current desire to be outside rather than recording this video for you all, by the way. That's just a coincidence that I thought to give this as an example. So here we have two statements on one side of the if and one statement on the other side. That's totally fine, right? So we can run this now. If it's cold, then it's... If it's cold enough, then we get two print statements, and if it's too hot, then we just get one line. The really interesting thing is that an if-else block, like we have here, is itself a statement. So if we wanted to go really super nuts, we could have an if inside an if. So let's think about where our program maybe is lacking a little bit right now is that, well, if I put that the temperature is minus 10 degrees, then the program is going to tell me it's nice outside, I should go enjoy it. I don't think minus 10 is that nice. So where would we test about the temperature now being low? Because we have an if-else, and those are kind of the two sides. It seems like, oh, that's it. Well, what we can do is we can have another if statement and think about where we would put it. Where would we test for it being cold? Well, it wouldn't be in this if condition up here, because this is already, if it's above 90, it's definitely hot. We need to put it down here only on this side to say, like, okay, if it's less than 90, it might be nice, but it might also be too cold. So let's put another if statement inside here, and I'll point out a couple things in a moment. So let's say if the temperature is less than 40, then we will call that to be cold. Sounds like a good message. And now we have our else. Okay, a couple things to notice here is that as I'm typing this, my text editor is nicely indenting things for me so I can see where each block ends and each one begins. And one place where it didn't is on these two lines because I didn't type them in as I was typing that else. But if you have a good text editor, then it should be able to correct that very easily for you. And all of the text editors that we're using for this class have the ability to fix that indentation. It's very important because otherwise it becomes really hard to read. If you have a lot of if-else and they're not lined up nicely, then it's very hard for any human that looks at that to understand, wait, does this line go with this else or this one? So use your text editor, and Dr. Choi and I are going to be ruthless. If you turn in stuff that's not indented right, you have no excuse. Your text editor can do it for you, and it makes it totally unreadable. So if you, that's something to just watch out for. You get some easy points and gratitude from your graders if you just get that aspect right. So what's happening here is that this is what's called a nested if statement. So inside the else condition, we're testing again a totally different thing. We don't even think about this test unless we end up in that else case. So back to our illustrations, what's going on with this program that I just wrote, if we think of it as a river, is we have our river flowing down. Here's the first if condition, and if it's hot, we go over to this side, and that's it. Then it just goes to the end of the program. But if it's not hot, then it actually goes to a different test to test if it's too cold, and then it goes over here, and otherwise the river kind of flows down, and then they all flow back together at the end. So this is the horrible looking picture, but the idea is that now we essentially have 3 streams because we've tested a second condition inside the first one. And this will work, I hope. Let's check it out. So compile and run. Now, what should we test? Well, now we have to test 3 different things to make sure our program works. Let's test a low temperature like -10. Okay, good. That worked. Now we have to test kind of a middle temperature like 55. Great. And we have to test a hot temperature as well to make sure that it works in all of those situations. And that's great. Seems to work all the time. This is super. One thing, however, this isn't perfect. So as we get into more advanced tools in this class, what we're going to see is kind of with... I would say it's like the Spider-Man thing, with great power comes great responsibility. So if-else is a very powerful construct, but it can also get quickly confusing because it's so powerful, right? So if you kept having more if-else and if-else inside everywhere, it's going to be really hard for someone that's looking at that program to figure out what it does. And a lot of times we can use not only the syntax of how our program looks, but also think about how to restructure things so that it's easier for someone to read and see what's going on. And in this case, there's a nice little shortcut, which is called the else-if statement. And I'll show you what that looks like. It's for a situation like this where you want to have one test, then test another thing, then test another thing, and they're all kind of related to each other. You want to take exactly one of these options. And another way to put it is that here we have kind of 3 options, but these 2 are like indented at a higher level. It makes them seem like less important, but they're just as important as the too dang hot outside option. And so what we can do is we take out this bracket and we just make this an else if statement. So now we'll re-indent everything to the right and remove the closing bracket from the other one that we took out. And so this is what it looks like. So we have lined up in the same place if, else if, and we could have more else if, and then a final else condition. And it kind of works like running downhill, testing each condition until it finds one that's true, or when it gets to the end and hits the else. So if this condition is true, that the temp is greater than or equal to 90, then I'll just do this and jump to the end. If this condition is not true, then it'll go and test the second condition, and then it'll either go here, or if they're both false, then it goes to the third condition. So this is a pretty common thing that you might have. Think of this as like a 3-way if statement with 2 things that we test, one after another. And then we can use this nice if, else if construction to make it a little bit more cleaner and easier to look at. So that's a small thing. There's a few other kind of nice shortcuts and simplifications like that are mentioned in the notes that I highly encourage you to read. And as you get more comfortable with if, else, and branching statements, incorporate them into your writing. Okay, so that's a little bit about if and else if. And there's just a few more comments that I want to make. Again, more details are in the written notes, and I don't want you to think that these videos are like a substitute for that. This is kind of just giving you an overview of the topic and pointing out a few of the most important things, but for the details, you should look at those written notes as well. So the other thing is, what is in that conditional? What's in the condition? Remember, the condition is like that question that comes when we have if and in here. This whole thing, what goes in here? So we just saw something like a numerical comparison. That's a very common thing. Comparison. And there is a number of them. So we just saw like 5 is less than or equal to 90. That is how we would do it, less than or equal to. Of course, you can also do it greater than or equal to, like 10 is greater than or equal to, well, it's greater than or equal to itself. You can also do a strict inequality, like 5.1 is strictly less than 5.2. So for there, you don't have the equal sign. And similar with strict greater than. And then for actual equality, this is the most important one. 15 is equal to 15, and we have to use two equal signs. And the opposite of equal is not equal, and that would be like 20 is not equal to 15. So for not equal, we use the exclamation point and then an equal sign, and they have to be right next to each other with no space in between. So the one that you and every other programmer, including me, always has a problem with is this equality comparison, because what is our tendency going to be is to write a single equal sign. And that can make a big mistake, because what does a single equal sign do in C? It does assignment. So you might want to do something like, if x is equal to 20, then something something. Well, this is always going to be true. Why? Because this does an assignment. It's a single equal sign. So this actually assigns x equal to 20, and then it returns the value that was assigned. So that would evaluate, this whole assignment would evaluate to the value of 20, which, remember, that'll be interpreted as a bool. So 20 being not 0, this whole expression now, which is kind of crazy, this whole thing evaluates to true. And then it'll always execute that thing inside, which is terrible. So it'll overwrite the old value of x. Not only have you not done the proper if-else, but it's also changed the value of x, and you probably never even get notified about it. So there's a couple tricks that you can do to get around it. You know, some people advise to write your equality checks the other way, like 20 equal x, because if you try to assign 20 equal x, the compiler will tell you that's a problem. But if I just have to write that the way to fix this is you need two equal signs. Equal is the way to do comparison correctly in C. So that's just a common error that can be really hard to catch. So just be double careful when you're writing an equality check that you use a double equal. So these are common straight up numerical comparisons. And along the same lines, we have one string comparison function right now. We'll learn more string comparisons later. But the one string comparison that we have for now is just string equality. So it's string EQ, and then whatever string is in there, we give it two arguments for the two strings that are being compared. Again, so we have to use some functions. This one comes from the IC210.h library. We have to use some functions because C-string is not a built-in type in C. So we have to use these kind of external functions. And how would you test that strings are not equal to each other? Or how would you combine any of these? That's when you want to use the Boolean operators. So that's like when you want to do a few comparisons at a time. Operators. And we've already seen these introduced. But they are like double. Oh, man. I'm bad at drawing ampersands. I also have to take a pause and think about it. I think this, yeah. So double ampersand for an and. There's a double vertical bars for or. You'll find the vertical bars near your backslash on your keyboard. And a single exclamation point for not. So for example, how would we test that two strings are not equal to each other? Is you just use that not operator. So we would say like not string EQ of like Dan and frog. I am not a frog. Last time I checked. So that's a useful thing. For example, if I want to check that a value is between two other values, I have to do two numerical comparisons and combine them with the AND operator. And you'll see more examples of this in the notes. And we could say more examples now, but really it's a matter of being aware of these, and then you have to kind of work through, and you'll get a lot better handle once you have more practice of using these. But they can make your conditions be a lot more powerful and simpler so that you can make your code as clear as possible. So that's it for variables and if statements. We covered a lot here, and I hope that it was kind of enjoyable, and I hope that you know that we're also just scratching the surface with all these things. Everything that we're learning, we're going to keep using variables and if statements, if else, and if, else if, throughout the whole semester, and you'll get just more and more comfortable, and you'll pick up on things which are ways to use all these tools most effectively as we go on throughout the semester. So this is not the end of us talking about variables and if, but it's just the beginning of us starting to use these cool features in C.